In this video, we're going to talk about how we can find out the volumes using so-called cylindrical shell. So the object in this form is called the cylindrical shell. Before we proceed on how we can use this kind of objects in order to find the volumes, let's find out the volume of this shell itself. So we are given the radius of outer circle, let's say R2, and also we're given the radius of the inner circle, R1. At the same time, we're given the height of the cylindrical shell. So do you see, so this is different from the cylinder because there is a hole in the middle of this object. So we've got just the walls here, and whenever we find a volume, so it depends actually on the thickness of this wall. So the idea of finding the volume is that we can find the volume of the outer cylinder, and then we can find the volume of the inner cylinder, and we subtract the volume of the inner cylinder from the outer one, which is going to give us the volume of the cylindrical shell. So the volume, so let me write down the outer volume. So we always find the volumes actually by multiplying the area of the base to the height, right? So the area of the outer volume, so outer circle is going to be pi multiplied to the RT in the square multiplied to the h, and the inner volume is going to be, again, the area multiplied to the h. In this case, the area is going to be pi multiplied to the r1 square multiplied to the h. So that is why the kind of the middle area, or the area, the volume of the cylindrical shell is going to be outer volume minus the inner volume. It's going to be pi r square, rt square, h minus pi r1 square multiplied to h. So we can take out the pi and h from the brackets. What we will get is rt square minus r1 square. We are going to rewrite this term in a different form. It's going to be pi multiplied to the h multiplied to the rt plus r1 multiplied to the rt minus r1. So we know that if you open up the two brackets, we're going to get exactly rt square minus r1 in the square. So what I'm going to do is I'm going to put here the 2 and multiply this to the 2. So these two equations actually are equal. So there is a reason why we wrote down these two things, so this one term and these two different terms. The reason is that R1 plus R2 over 2 is actually the average radius. So the average between R1 and R2. So graphically, it's going to give us the radius until basically the middle of this wall, right? Of the thick wall. So I'm going to denote this as the R. So this is going to be denoted as simply R. And RT minus R1, which is basically the thickness of the walls of the cylindrical shell, is going to be denoted as the delta R. So this term is going to be denoted as the delta R. So we've got a formula to find the volume of the cylindrical shell. So the volume is going to be to 2 pi R multiplied to the h multiplied to the delta R. So this formula we're going to use in order to find the volumes of any object. So let's consider an example. So now let's talk about the idea of how we are going to find the volumes. Volumes using the cylindrical shell. So let's say I've got a function which is going to look like this. So this is going to be our function f of x. So what we're going to do is we are going to rotate this function around the y-axis so that we are going to get this kind of object. So now it's going to be very difficult to find the volume of this object by creating the slices. So previously we created a lot of slices and we found out the areas of the slices. It's going to be kind of difficult for us to create the slices. Instead of creating the slices, we're going to put a lot of cylindrical shells. So basically the idea is like this. So I'm going to choose any point for example, here on the x, so this point, it's going to be some point x, okay? Then at this point, I'm going to create a cylindrical shell. So I'm going to put the x here, the x here. So it's going to be a cylinder, right? And I'm going to create a little, the shell with the really thin thickness. So it's going to be delta R here. So the idea is, so the volume of the cylindrical shell is going to be, so if you remember the formula, it was 2 pi r multiplied to the h multiplied to the delta r. So in our case, delta x in our case, the volume of this red cylindrical shell is going to be equal to, so what's the radius between, so what's the radius of the cylindrical shell? So the radius, until the middle of the cylindrical shell, it's going to be exactly this point, right? X actually. So radius is actually equal to the x. So the volume of the red object is going to be equal to the 2 pi multiplied to the radius, in our case is x, multiplied. What's the height of the cylindrical shell here at this point x? So here at this point, height is going to be the y coordinate of this point, right? So we can find all the coordinates of the points here using the equation of the function. So basically here at this point x, the height of the cylindrical shell is going to be f of x, right? This is the height multiplied to the delta x. So well, this is just the volume of one cylindrical shell with the very small thickness of the wall. So the idea is we can create a lot of cylindrical shells. So we can create a cylindrical shell here, then we are going to create a cylindrical shell here, for example, and so on. So we can create a lot of cylindrical shells, and by summing the volumes, we can find the overall volume of the object. So basically, overall volume is going to be equal to the summation of 2 pi xi multiplied to the f of xi multiplied to the delta x, where I goes from 1 to the n. So we are going to create a lot of points on the x-axis here, right? Starting from 0 until this point. Not from 0 actually, from A to the B, right? So it should start from here until here. So from A to the B. And then we're going to create lots of cylindrical shells, and by finding the sum of their volumes, we can find the overall volume of the object. So we can create the exact volume if the number of those cylindrical shells goes to the infinity, right? So it means that the volume can be found by integrating this function 2 pi x multiplied to the f of x dx from A to the B. So this is how we're going to find the volumes. So let's do an example. So let's say we're given a function y is equal to the 2x squared minus x cubed, and also y is equal to the 0 line. We have to rotate this curve around y-axis, and then we have to find its volume. So let's try to do this. So this function is roughly going to be given like this. So like this roughly. So this is the y-axis, and this is going to be the x-axis. So I would like to find the roots of this function. So what does it mean? It means that at which point on the x-axis, the y is going to be equal to the 0. In order to do this, I'm going to take out the x squared from the brackets, and what is left is t minus x. It means that y is equal to the 0 when x is equal to the 0 and when x is equal to the 2. So what we have to do is we need to rotate this curve, right? So y is equal to the 0 line is going to be this line actually. So this is all the points on this line have the y is equal to the 0 coordinates. So I have to rotate this curve around the y-axis. What I'm going to get is, so let me count 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. So we are going to, if we rotate, we are going to get roughly this kind of object. So it's going to be a circle around it. So I'm going to show you here the figure of the object which we're going to obtain if we rotate this around the y-axis. It's going to be roughly like this if we rotate. So the volume of this object we are going to find. And actually the idea is to create a lot of cylindrical shells. For example, we can create a cylindrical shell here at the axis equal to the 0.5, let's say. So it's going to be a this kind of cylindrical shell. And the idea is to create a lot of this kind of cylindrical shells. So let's say I choose the point here as x, right? So this is going to be the radius of the cylindrical shell. So the radius of the cylindrical shell is going to be equal to the x. And the height of the cylindrical shell, h, is going to be equal to the f of x. In our case, it's going to be x squared multiplied to the t minus x. And basically we're given everything else. So the volume of this object is going to be the integration of the 2 pi x multiplied to the f of x dx, and we have to integrate this from 0 to the 2. Basically, we're going to choose the points in order to create the cylindrical shells from 0 to the 2 over the x-axis. The rest is the technical calculations. It's going to be from 0 to the 2 pi multiplied to the x multiplied to the f of x in our case as 2x squared minus x cubed, and we have to integrate this with respect to the x. I'm going to take out the 2 pi out of the brackets, and what we're going to have here is 2x cubed minus x in the power of 4 dx. We first of all find the antiderivative. Antiderivative in this case is going to be 2x in the power of 4 over 4 minus x5 over 5. And we have to evaluate this at the 0 and 2. So let's substitute the 2 instead of x. It's going to be 2 pi multiplied to 0. So I can cancel this. 4 and 2. What we'll have here is 2 in the power of 4 over 2 minus 2 in the power of 5 over 5 minus 2 pi multiplied to 0 in the power of 4 over 2 minus 0 in the power of 5 over 5. So obviously the second term is going to be equal to the 0. So we just need to calculate the first term. It's going to be 2 pi multiplied to the 2 in the power of 4 is 16 divided to the 2, it's going to be 8 minus 2 in the power of 5 is 32 divided to the 5. So I'm going to give the common denominator. It's going to be 5 multiplied to the 8. It's going to be 40 minus 32. It's going to be 8. So it's going to be 2 pi multiplied to the 8 over 5, or it's going to be equal to the 16 pi over 5. So this is the volume of this object, and we found this using a lot of cylindrical shells. So this is the method. It's called the cylindrical shell. So in the next videos, we're going to talk about examples, more examples.